In this section, we want to learn about how to add and subtract the rational expressions. When we add fractions, if the denominators are the same, then we can leave the denominator the same and we can add or subtract the numerators. However, if the denominators are different, then we have to figure out the least common denominator. The least common denominator is the least common multiple of what appears in the denominators in the two fractions. In the next example, what we want to consider is figuring out the least common multiple of 6x to the fourth power and 9m to the third power to practice to figure out the common denominator. When you do that, we have to factor both. 6 can be factored into 2 times 3, and let's leave x to the fourth power as it is. 9 can be written as 3 times 3. And we have m cubed. When we figure out the least common multiple, what we will do will be we will essentially write all the factors that appears here because that must be the multiple of the first one and the second one. However, if there is a common factor, in this case, these 3 and these 3 are the common factors. So if that appears in both, then we will write it only once. So I would write 2 and 3 and x to the fourth power, and we have 3, but 3 appears twice, so I will not write this 3 again, and I will write m cubed. When we multiply all these numbers, we will get 18, and then x to the fourth power times m cubed. When we say two fractions are equivalent fractions, the other fraction is obtained by multiplying the same number on the numerator and the denominator. For example, we have 3 over 5. If we multiply 2 on the numerator and denominator, then we will get 6 on the numerator and denominator is 10. So we can say that 3 over 5 and 6 over 10 are equivalent rational expressions. In the next case, we have 8x over x minus 3. Whatever that is, we can multiply to the numerator and denominator. When we do that, the multiplication to the numerator and denominator must be the same. In this example, we are multiplying x plus 5 to the numerator and to the denominator. When we expand that out, 8x times x will make 8x squared. 8x times 5 will make 40x. And denominator, you can expand it out or you can leave it like x minus 3 times x plus minus 5. Those two are the same fraction. In the following problem, we want to figure out the equivalent form of the fraction to w plus 4 over 5 minus 3w. The way we want to understand the second fraction on the right side will be that's transformed from the first one, 5 minus 3w. We find that the second fraction, denominator of the fraction on the right side, can be decomposed to 6 times 3w minus 5. What we know is the position of 5 and 3w are switched. So what we can do for that is when we understand the fraction on the right side is the transformed fraction from the left side, we just write what's in there. But what we realize is these two positions are switched. So I would multiply by -1 for that. And when we decompose the denominator on the right side, that was 6 times 3w minus 5. So I would write 6. When I do that, I have to do it on the numerator and the denominator. So I would write -1 times 6 on the numerator also. Then what do I get? Because of pre-manipulation, what happens here is -6 times 5 will be -30, and negative will be positive, plus 6 times 3 will make 18w. And numerator will be -6w minus 24. So this is the final fraction that's equivalent what's written on the left side. Add or subtract. The first problem is 7 over z plus 6 over z. Two fractions denominators are the same, so we can just extend the middle horizontal line and keep the denominator the same, and we just add the numerator, then it'll be 13 over z. In the second problem, the denominators are the same. Those are 8y, so it is 11y plus 2 minus 5y. So that's 8y in the denominator, and numerator, we add the number together, 11 minus 5, which is 6y, and plus 2. Let's take out 2 on the numerator and denominator. So if we take out 2, then 2 times 3y plus 1 over 2 times 4y. Those two cancel each other, and we get 3y plus 1 over 4y. In this problem, we have 7 over 2u squared minus 2 over 5u cubed. Two denominators are different, so we have to consider the least common denominator. To do that, we have to analyze the denominators. 2 and 5 are prime numbers, and u are the same base numbers. So we will decompose the higher degree term to u squared times u to the 1 power. By doing so, we can make a common factor u squared. So least common denominator will be 2 times u squared times 5 times, skip this u squared because that happens in both. So, and we already wrote it here. So you just write down u here. 2 times 5 will make 10, and u squared times u will make u cubed. Let's convert each fraction to the equivalent fraction with the least common denominator. The first one is 7 over 2u squared. What's missing here is this part. So 5u over 5u will be multiplied. Then that'll be 35 over 10u cubed. What is important? We multiplied 5u to make this least common denominator, and we do the same thing on the numerator. The next one is 2 over 5u cubed. When we compare this denominator with this least common multiple, that'll be, the difference will be just 2, because 5u times u squared will make u cubed. So this part is the denominator, and 2 is missing. So we will multiply by 2 on the numerator and denominator. So that'll be 4 over 10u cubed. Let's rewrite it. Then the first fraction was 35 over 10u cubed minus the second fraction is 4 over 10u cubed. So that's 10u cubed in the denominator, and the numerator is 35u minus 4. I missed here u, so I'm putting there. In the next problem, we want to calculate 11 over 2x minus 4 minus x over x minus 2. Two denominators are different, but we can easily recognize that the first denominator is twice more than the second denominator. So we can decompose it to 2 times x minus 2. So when we consider the least common denominator, indeed the least common multiple is what's in the first denominator. So we don't have to do anything for the first fraction because that already have the least common denominator. And we copied 11 over 2x minus 4 minus the second fraction is x over x minus 2. But to make the least common denominator, we have to multiply by 2 to the numerator and denominator. Now we have the same denominator, 2x minus 4. So we can combine the numerator together. So 11 minus 2x. Or you can write 11 minus 2x over 2 times x minus 2. If you like the factored form more. The next problem is 3 over 5x minus 4 minus 6 over 4 minus 5x. Obviously, both are different fraction, but we know that the second one has a flipped position. Let's consider another expression of the same situation. We can rewrite it as 3 over 5x minus 4 plus minus 1 over 6 over 4 minus 5x. This minus 1 can be regarded as 1 over negative 1. So let's write down again 3 over 5x minus 4 plus 1 over negative 1 times 6 over 4 minus 5x. So that's 3 over 5x minus 4 plus we multiply like this, then the numerator will be 6 and the denominator will be 5x minus 4. We have the same denominator, so we can just add them up in the numerator. So 3 plus 6. So then that is 9 over 5x minus 4. Now we want to learn about the complex fraction, which is fraction over fraction form. Before we move on to that subject, let me remind you that a over b can be rewritten as a times 1 over b because a is indeed a over 1. So these two are left side and right side are the same. And we also know that a over b is indeed a divided by b. When we think about a over b, that means a times 1 over b. What is 1 over b? That is the reciprocal. reciprocal of b. b is in the denominator, so reciprocal of the denominator. So a over b can be considered as numerator times the reciprocal of the denominator. Let's consider the complex fraction a over b over c over d. In this case, a over b is the numerator and c over d is a denominator. What I told you was that fraction in general, numerator over denominator, can be calculated as numerator, which is in this case a over b, times the reciprocal of the denominator, meaning we have to flip the position of the numerator and denominator in the fraction in the denominator, so it becomes d over c. We want to simplify 2 over 3 over 9. This 2 over 3 is a numerator and 9 is a denominator. So always keep in mind, when we simplify the complex fraction, we will multiply the numerator times the reciprocal of the denominator, which is 9. So reciprocal will be 1 over 9. So that's 2 over 27. In this case, 9 is the numerator. 3 over 7 is a denominator. So it is 9 times the reciprocal of the denominator, which is 7 over 3. So 9 over 1. What is 9? 9 is 3 times 3. So do 3 on the numerator and denominator will cancel each other. And we have just 1 on the numerator and 1 in the denominator and 3 times 7 in the numerator. So 21 is the final answer.